Hello learners, I am Dr. Subodh Kesharwani, working with Indira Gandhi National Open University in School of Management Studies as an Associate Professor. The topic which I am going to talk today is a sequel to what we have discussed in our previous session, that is related to time series components. In the previous session we have talked about time series analysis, and today we are going to discuss about time series components and decomposition. So prior to going into the depth of this topic, I think we just want to throw a light that this is part of our course called MCO3, Research Methodology and Statistical Analysis, and we are here in the third block which emphasizes more on trend analysis. So when you are going to talk about the trend analysis, the first the ingredients which comes in your mind is the correlation regression analysis, which we have already covered in our preceding session, and then the time series is there, and then index number is there. So we are in the mid of this particular block and focusing on the time series component. So prior to going into the depth of this components, I just want to recapitulate that time series. If we talk about it's the prediction, or rather we can say the trend in financial market or electricity consumption or time is an important factor that must be considered in our models. So time series is simply a series of data points ordered in time, and in a time series, time is often the independent variable, and the goal is usually to make a forecast for the future. So we have seen in the trend, we have seen in the regression and correlation that how this independent variable and dependent variable varies, and we see that how when we talk about the correlation, how two variables talks about the view and or the relationship, whereas when you are going to talk about the regression analysis, it is more talking about the trend analysis. So in regression analysis we have seen that dependent variable is 1, but independent variable is more than 1. So in that case we are getting the multiple the view about the thing. So anyway, I think we are more focusing on the time series components in this particular session, and time series is a realization of sample function from a certain stochastic process. A time series is a set of observations generated sequentially in time, therefore they are dependent to each other. This means that we do not have a random sample, and we assume that observations are equally spaced in time, and we also assume that close observation might have stronger dependency. So when we are going to talk about the objective of time series analysis, I think understanding the dynamic or time dependent structure of the observation of a single series, that is univariate analysis, and forecasting of a future observation, ascertaining the leading, lagging and feedback relationship among several series, that is multivariate analysis. So we are here to discuss about the 4 important components of time series, though it's not confined to these 4 components, there are some more components, but since we are talking in an omnipresent manner, so just focusing on the 4 important components, that starts with the trend component, then you have a seasonal component, then you have a cyclical component, and finally the irregular and random components are there. So if we go into the backdrop and just throw a light on this particular term, I think when we emphasize on the term called component of time series, I think it's bifurcated into long-term movement, then short-term movements, and random or irregular movements. So you will see that this short-term movements is bifurcated into seasonal variation and cyclical variation. So this particular if you talk about this short-term movement, so seasonal component and cyclical component are more emphasized on the short-term movements, whereas the trend component emphasized on the long-term movement, and then you have a random or irregular movements which is taken care as a different head. So trend component is more focusing on the overall persistent long-term movement. Seasonal component is regular periodic fluctuation, usually within a 12-month period, and when you're talking about cyclical component, repeating swings or movements over more than 1 year. And finally the irregular and random components, that is erratic or residual fluctuations are there. So anyway, if you talk about the secular trend which describes the movement along the term, seasonal variation represents seasonal changes, cyclical fluctuation correspond to periodical but not seasonal variations, and irregular variations which are other non-random sources of variation of a series. So if we see the image, I think the image is quite self-explanatory in nature. Start with the trend, and you see how the trend is changing with the change of time, and random movement is there, and we are emphasizing more on the long-term movement. On the other hand, if you see the seasonal, I think it's moving in a zigzag manner, and as per the season, as per the pattern, the things are changing. Cycle more or less talks about that pattern, and this is where the x-axis talks about the time, y-axis talks about the demand, and on the basis of that we have plot the graph. So we will usually go into the depth of all these components on a one-to-one basis, and then finally talk more about it. So the trend component, if you talk about the trend, is a long-term evolution of the series that can be observed on several decades, and the cycle component is the smooth and quasi-period movement of the series that can usually be observed around the long-term trend. So the seasonal component talks about the seasonality and fluctuation observed during the year, each month, each quarter, and which appear to repeat themselves on a more or less regular basis from one year to that. So, and the calendar effect, if we talk about any economic effect which appears to be related to the calendar, if we talk about the irregular component composed of residual and random fluctuations that cannot be attributed to the other systematic components. And on the other hand, finally we have outliers. So different kind of outliers can be defined. We have talked about the outlier in measure of center tendency. When we see that that average is there, when we are going for taking the average, there are certain components which differs from one another. So if the numbers are 10, 15, 20 or 25 which are quite near to one another, and there is another number which comes to 90. So if you take an average, I think this measure of center tendency is not going to give you that much result. So for that you start moving towards the measure of variance or the standard deviation. So this is the trend which is there. So if we talk about the first component, the trend component is defined as a long-term movement. We have already have a comparative view, and the trend is a reflection of the underlying level of the series. This is typically due to influences such as population growth, price inflation, and general economic development. And the trend component is sometimes referred to as the trend cycle. And if we see this particular image, I think this image is quite explanatory, where we have seen that we have plotted on at the x-axis we have time, at the y-axis we have sales, and we have plotted the dot. The first instance was the plotting the dot on the basis of the values given in the variable, and the moment we have plotted the dot, then we have started putting the lines. So there are two ways to do it. If you see we have plotted the graph, then the zigzag image had come up, which is going upward, then coming down, then going upward, then coming down, and finally going upward trend. And when you make a regression line, I think the graph itself shows that it is moving in a upward trend. It's have a upward trend. So the long run increase or decrease over time is there, data taken over a longer period of time. So this is the USP of trend component. And if you go more into the depth of this trend component, you will find out that it's have a linear trend as well as non-linear trend also. So when you are, and if you see this image shows that how the downward linear trend is there. So trend component is more talking about trend can be in a upward direction or in a downward direction. Trend can be linear or non-linear. If you see this particular image, I think that image itself is quite explanatory, that though it's linear in nature, but the trend is downward. And if you see this non-linear graph, I think the trend is upward, but the graph is non-linear. So we can very easily depict that the image is talking about having a downward linear trend, and when you are going to talk about it's having an upward non-linear trend. So now the second component is the seasonal adjustment component. Seasonal adjustment is a method of data smoothing that is used to predict economic performance or company sales for a given period. And this is varies from 12 months to 1 year. We have already talked about. And the seasonal adjustment provide a clearer view of seasonal trends and cyclical data that would otherwise be overshadowed by the seasonal differences. Now the question is that why seasonal adjustments are there. So the aim of the seasonal adjustment is to eliminate seasonal and calendar effect. Hence there are no seasonal and calendar effects in a perfectly seasonal adjusted series. So if we talk in other words, I think seasonal adjustment transforms the world we live in into a world where no seasonal and calendar effects occur. So in a seasonally adjusted world, the temperature is exactly the same in winter as in the summer, and there are no holidays, like like Diwali is abolished because people work every day in the week and with the same intensity, no break over the weekend. So how does seasonal adjustment work? Now the question is that, so seasonal adjustment is a statistical technique that attempts to measure and remove the influences of predictable seasonal patterns to reveal how employment and unemployment changes from month to month. So, as a general rule, the monthly employment and unemployment numbers reported in the news are seasonally adjusted data. So, this is what the seasonal adjustment work is, and they are cause of seasonality. Seasonality and climate due to variations of the weather and of the climate. So, example given, agriculture, consumption of electricity, heating. I think when summer comes, there is more consumption of AC or the refrigerators. So these are considered to be the seasonal or climatic changes. Seasonality in institutions, if you talk about, due to the social habits and practices or to the administrative rules. So there are certain examples to that: effect of Christmas on the retail trade, of the fiscal year, on some financial variables of the academic calendar. So indirect seasonality, if you are going to talk about, due to seasonality that affects other sectors. So toy industry is affected long before Christmas. A seasonal increase in the retail trade has an impact on manufacturing, deliveries, etc. So seasonal adjustment is the process of estimating and removing the seasonal effects from a time series, and by seasonal we mean an effect that happens at the same time and with the same magnitude and direction every year. And the basic goal of seasonal adjustment is to decompose a time series. We will definitely talk about what exactly the decompose is and how it differs from how it had going to play a very important role when we are going to talk about the decomposition. So into several different components, including a seasonal component and an irregular component. So because the seasonal effects are an upward feature of the time series, seasonal adjustment can be thought of as focused noise reduction. So seasonal effects are annual effects. The data must be collected at a frequency less than annually, usually monthly or quarterly. And for the data to be useful for time series analysis, the data should be comparable over time. This means that the measurement should be taken over discrete, non-overlapping consecutive periods, that is every month or every quarter. And the definition of the concept and the way it is measured should be consistent over time. So what we are going to do, that keep in mind that longer series are not necessarily better. If the series has changed the way the data is measured or defined, it might be better to cut off the early part of the series to keep the series as homogeneous as possible. And these adjustments we have to do in seasonal adjustment. The best way to decide if your series need to be shortened is to investigate the data collection methods and the economic factors associated with your series and choose a length that gives you the most homogeneous series possible. So I think when you're going to more into the depth of seasonal adjustment, during seasonal adjustment we remove seasonal effects from the original series, and if present we also remove calendar effects. The seasonal adjusted series is therefore a combination of the trend and irregular components. And one common misconception is also there, is that seasonal adjustment will also hide any outliers present. I think outliers we have already discussed in measure of center tendency, that it is a unwanted number which can affect the average in a big manner. So if you go for the stereotype averages, there the big, so we have to hide any outlier, because outlier is going to massively affect the thing. So this is not the case. If there is some kind of unusual event, we need that information for analysis, and outliers are included in the seasonal adjusted series. Now this is the image which we are taking here, and which can with the change of weather you see how the trend is going to change. In winter the dot is at the upward direction, in spring it's coming down, then summer is going up, then fall in this. So short term regular wave like patterns are there and observed within 1 year, often monthly or quarterly, and you find out that what exactly the trend is. So if you see this particular image, I think this image is quite explanatory, where we have Q1, Q2, Q3 and Q4. There are certain figures which pertains to certain years like 2017, the Q1 100, 200, 130, 250, same as in 2018, 2019, 2020. Now what we are going to do, we are taking a difference of that. So Q2 with respect to Q1, it's coming plus 100, and this is coming 120 minus 90, it comes to 30, and then 250 minus 150 comes to 100. So this is the manner by which we have done it, and then we have taken from third to second quarter in the same manner we have done it. So 130 minus 200 gives the negative figure. and 100 minus 120 gives again a negative figure. So now what you observe that the negative value comes. So this is called seasonal adjustment. So anyway, now cyclical component is going to be there, and this cyclical component is talking about long-term wave-like patterns regularly occur but may vary in length, often measured peak to peak or trough to trough. So this is talking, if you talk about the peak is this, and trough is the downfall. So when anything comes down, so unpredictable random residual fluctuations, noise in the time series, the truly irregular component may not be estimated. However, the more predictable random component can be estimated and is usually the emphasis of time series analysis via the usual stationary time series models such as AR, MA, ARMA, etc. after we filter out the trend, seasonal and other cyclical components. So the irregular component is the remaining component of the series after the seasonal and trend components have been removed from the original data, and for this reason it is also sometimes referred to as a residual component. So it attempts to capture the remaining short-term fluctuations in the series which are neither systematic nor predictable. So on the other hand, we have some additional components which is like additive outliers, transitory changes or level shift. So if we talk about outliers, additive outliers, unusual high or low singular values in the data series, and transitory changes is in the trend followed by slow comeback to the initial tendency and assimilated to the irregular component. And when you talk about the level shift, clearly changes of the trend assimilated to the trend component. So the smoothness of series can be decided by the statisticians and the policy must be defined in advance. Consult the user. The choice can influence dramatically the credibility. Outliers in the last quarter are very difficult to be identified, and there are certain suggestions which need to be incorporated. Look at the growth rates. Conduct a continuous analysis of external sources to identify reasons of an outlier. Where possible, always add an economic explanation and be transparent. And this is another type of calendar adjustment. The calendar effect typically include different numbers of working days in a specific period, composition of working days, leap year effect, moving holidays, Easter, Ramadan, etc. And then calendar adjustment trading effect is there, where recurring effects associated with individual days of week, and this occurs because only leap year Februaries have 4 each type of day. So 4 Mondays, 4 Tuesdays, etc. All other months have an excess of some type of days. So if an activity is higher on some days compared to others, then the series can have a trading day effect. For example, building permit offices are usually closed on Saturday and Sunday. Thus, the number of building permits issued in a given month is likely to be higher, and if the month contains a surplus of weekdays, and lower if the month contains a surplus of weekend days. So calendar adjustment works on the moving holiday effect, where effect from holidays that are not always on the same day of a month, such as Labor Day or Thanksgiving Day. So the most important moving holiday is applicable in European countries is Easter, not only because it moves between days but also because it moves between months, since it occurs in March or April. Now since we have talked about the certain components of time series, we are going to throw a light on what exactly the decomposition is. So decomposition of a time series is basically an analysis of time series are one or the same thing. The original data are observed as data 0 is the result of the effect generated by long-term and short-term cause, namely trend is specified as or abbreviated as T, cyclical as C, seasonal as S, and irregular as I. Now finding out the values of each of the components called the decomposition of a time series, and decomposition is done either by additive model or multiplicative model of analysis. Which of these two models is to be used in analysis of time series depends on the assumption that we might make about the nature and relationship among the 4 other components. So usual additive and multiplicative model is X is equal to trend, cyclical, seasonal, and what we have talked about, irregular. So this is the formula which is there. So xt is equal to TET multiplied by CT multiplied by seasonal T and multiplied by IT. So this is the formula which we have developed. More components, outlier, calendar effects are there. So if you talk about decomposition model, the trend, some usual shapes as far as decomposition is there. Trend looks like this, seasonality looks like this, additive model looks like this, and multiplicative model looks like this. So it is based on the assumption that four components are independent of one another. Under this assumption, the pattern of occurrence and the magnitude of movements in any particular components are not affected by the other components. In this model, the values of the four components are expressed in the original unit of measurement. Thus, the original data or observed data y is the total of the four components value, that is y is equal to t. Trend, S stands for seasonal, C stands for cyclical, and I stands for irregular. So what we have observed that these are the the variation, trend variation, seasonal variation, cyclical variation, erratic variation respectively are quite important. So this multiplicative model, if you are going to emphasize, it is based on the assumption that causes giving rise to the four components are independent. Thus the original data or observed data y is the product of four component values. In this model, the values of the component except trend values are expressed as percentage. And if you talk in business research terms, which normally the multiplicative model is more suited and used more frequently for the purpose of analysis of time series, because the data related to business and economic time series is the result of interaction of a number of factors which individually cannot be held responsible for generating any specific type of variations. So what we have observed that there are certain preliminary adjustments, and before we proceed with the task of analyzing a time series data, it is necessary to do relevant adjustment in the raw data. Calendar variations, if you are talking about, as we are aware that all the calendar months do not have the same number of days. For instance, the production in the month of February may be less than other month because of fewer days, and if we take the holidays into account, the variation is greater. Therefore, adjustment for calendar variation have to be made. Price changes, as price level changes are inevitable, it is necessary to convert monetary values into real values after taking into consideration the price indices. In fact, this is the process of deflating, which will be discussed in the forthcoming presentation under the ambit of index number. So population changes, if you talk about, population grows constantly. This also calls for adjustment in the data for the population changes. In such cases, if necessary, per capita values may be computed, dividing original figures by the total population. I think we have talked a lot about this particular term called time series, which is a very important ingredient as far as the trend analysis is concerned. After the correlation regression, and this particular block, which considered to be the third block, and more focus on the trend analysis. So what exactly we will do in our coming sessions, when we are going to talk more about the index numbers, I think this can complete this whole block, and then we can move into the testing stage. So this particular course is more focusing on the research methodology as well as statistical analysis, and taking into consideration all these ingredients, which plays a very vital role as far as building the statistical concept is concerned. So thank you, learners. We will have some more thought-provoking sessions which will talk more on the research and statistical analysis in coming days. Thank you very much.